Hey guys, I hope your formatives went well today. I know they probably did because you guys are just awesome. Anyways, in 6.2 we're going to be talking all about parallelograms. There will be a lot of theorems, so just bear with me. We will only look at the proof to one of them. You will prove a couple of them in your homework later on, not tonight. But anyways, let's go ahead and get started. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So very self-explanatory. So let's look at another definition. Alright, here are a couple of definitions that we will be using in the theorem. So just so we're on the same page, let's take a look at these. The first one is opposite sides. And these are sides that do not share a vertex. Therefore, they would be opposite of each other. Opposite angles are angles that do not share a side. So, for example, angles B and angle D would be opposite of each other because they do not share any sides. And consecutive angles are going to be angles of a polygon that do share a side. So, for example, angle B and angle C are consecutive. Angle A and D are consecutive. Angle C, D are consecutive, angle B and A are consecutive to each other. Here's our first theorem about parallelograms. It says that if a quadrilateral is a parallelogram, then its opposite sides are congruent. Take a second, see if you think what would lead to proving that the opposite sides are congruent to each other. For the proof, we are given parallelogram ABCD. We want to prove AB is congruent to CD and BC is congruent to DA. By the definition of parallelogram, we know that the opposite sides are parallel to each other. So AB is parallel to CD and BC is parallel to AD. When you construct line segment AC, you see that you have alternate interior angles. So angle 1 is going to be congruent to angle 4, and angle 3 is congruent to angle 2. By the reflexive property, we know that AC is congruent to AC. Therefore, triangle ABC and triangle CDA are going to be congruent by angle side angle. And then we can use our CPCTC to prove our given, which is exactly what we wanted to do. Sorry, not prove the given, prove what we wanted to prove in the first place. Here's our second theorem. It says that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And remember, consecutive angles are the angles that are beside each other. We're not going to prove this one here, but you guys are going to be responsible for proving this one on your own. But here's a hint. You know angles B and angle C are consecutive, and you have some parallel lines and a transversal, and that's probably all I need to say about that. Based on our previous theorem, let's look at this example and find the measure of angle P. In this example, we see that angle S has a measure of 64. Angle P is the angle that we are looking for. Angle P and S are consecutive, therefore we know they are supplementary and will sum to 180 degrees. So a little bit of subtraction is all we need. 180 minus 64 is going to leave us with 116. So therefore the measure of angle P is equal to 116 degrees. Our next theorem states that if a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay, let's think about this for just a second. If we're going to try to prove it, then we know angles A and angle B, they will be supplementary because they are consecutive. Angles B and C are going to be supplementary because they are also consecutive. Since angle A and angle C are supplementary to the same angle B, we learned this theorem back a few chapters ago, then we're going to know that angles A and angles C are congruent to each other, since they are supplements of the same angle. Similarly, you can say that the other two angles, B and D, will also be congruent to each other. Okay, here's our last theorem. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So if you have quadrilateral ABCD, then you know if you construct the diagonals, then AC and BD, their intersection will bisect each of those line segments. All right, here's our first example with some fun math. What we want to do is we want to solve using a system of linear equations to find the values of x and y. So based on our previous theorem, we know that x is going to be congruent to y plus 2. So x must equal y plus 2. Similarly, we also know that y plus 10 equals 2x minus 8. So let's write that one down. Now remember, you guys know several ways to solve systems of linear equations. You could use elimination, substitution, you could graphically solve it. In this case, since the x is already isolated, I'm thinking that substitution is going to be the easiest. So let's plug in x into our second equation. So let's plug this in right there. So we're going to have y plus 10 equals 2 times all of that, y plus 2 minus 8. When we distribute, we're left with y plus 10 is equal to 2y plus 4 minus 8. Combining like terms on the right side leaves us with 2y minus 4 on the right. Subtracting y from both sides, 10 equals y minus 4. And then when we add 4 to both sides, we find that y is equal to 14. Now that we've solved for y, we simply just have to plug it back in to our first equation. This one would be the easiest to solve for x. So x is equal to 14 plus 2. Therefore, x is equal to 16. And we're all done. All right, you guys are going to kill me, but there's one more theorem. Sorry, I totally forgot about this one. This one says that if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So if all of these lines are parallel to each other and the segments that they create are congruent to each other, then we know any transversal you cut through here, all those segments that are created are also going to be congruent. All right, last example. This one's pretty easy. In this example, we know that AE is going to be parallel to BF, which is parallel to CG, which is parallel to DH. And we're also given information that AB is equal to BC, therefore they must be congruent, which is equal to CD. They also all equal 2. We also know that EF equals 2.25. By the theorem that we just learned, since we have 3 or more parallel lines and the transversal created congruent segments, then the other transversal must also create congruent segments. What we want to find is what is the measure of EH. Let's highlight that right there. So we're looking for that measure. If we know that EF was 2.5, then you probably know what to do. This must also, 2.25, then this is also 2.25. And 2.25 plus 2.25 plus 2.25 will give you 6.75. Therefore, EH equals 6.75. All right, you have 4 practice problems to do on your own. 3 of them are very easy. Only practice number 2, it is a proof please do try your best so when we go over it tomorrow, you have something to work with. Here are numbers 3 and 4. All right, guys, that's it. See you guys tomorrow.